Hello friends, welcome to my channel Technical Arquent. Myself Arnab Kundu. Today I will discuss the D flip-flop and T flip-flop. Okay, so go for it. Now I will discuss D flip-flop. Okay, D flip-flops are used as a part of memory storage elements and data processors as well. Okay, D flip-flop can be obtained from SR flip-flop by just putting one NOT gate, means an inverter, between S and R terminal. Okay, actually in that part we are say that it is a SR flip-flop, and if this is S and R, so we are just put an inverter to form this D flip-flop. Okay, D flip-flops are also called as delay flip-flop or data flip-flop. They are used to store 1-bit binary data. Okay, a flip-flop is constructed by modifying an SR flip-flop like that. The S input is given with D input and R input is given with inverted D input. The clock has to be high for inputs to get active, means clock value should be 1. Okay, that means S here go D, means S value is the D, but the R value is just complement, means we are using an inverter. Okay, so this is the truth table for D flip-flop. Okay, and D has two combinations, either 0 or 1. So and the clock should be 1. When D is 0, we get as a next state also 0. Okay, means whatever the present state 0 or 1, the next state always 0. Okay, and when D value is 1, the next state always 1, means whatever the present state 0 or 1, the next state always 1, and the Q complement is just reverse of Q. If it is 0, so is a 1. If Q is 1, so Q complement also 0. Okay, now this is the characteristic table for D flip-flop, which I got from the truth table for D flip-flop. Okay, so the clock pulse all are 1, means high, and for D is there either 0 or 1, and when D is 0, the present state either 0 or 1, and in both cases we got the next value as 0. Why? Because in truth table we already described that when D is 0, so Q always 0, whatever the present state. So that means whatever the present state 0 or 1, next state always 0. And the second one, when D value is 1, whatever the present state is concerned 0 or 1, the next state always 1. So that's why D value is 1, so Q value is always 1. Okay, so this is an excitation table which I got from this characteristics table for D flip-flop. Okay, so when present state and the next state, there's a 4 combination, either 0 0 0 1 1 0 and 1 1, and according to that whatever the D value, when present state is 0 and the next state is 0, so this is the combination 0 and 0. So what is the D value? Also 0, and there is no other 0 0 is there, so that's why D is 0. When present state is 0 and next state is 1, so this is the combination 0 and 1, so we got D is 1, so that's why D value is 1. When present state is 1 and next state is 0, so we got 0 as D value, so present state is 1 and next state is 0, so we got 0 as D value. And when the present state is 1 and the next state is 1, we got 1 as D value. So when present state is 1 and the next state is 1, so we got D as 1. Okay, we discussed the T flip-flop. The name T flip-flop is termed from the nature of toggling operation. Okay, T stands for toggle, so it is called toggle flip-flop. Okay, the major applications of T flip-flop are counters and control circuits. Okay, T flip-flop is modified form of JK flip-flop, making it to operate in toggling region. Okay, the clock has to be high, means always clock should be equal 1 for the inputs to get active. Okay, T flip-flop can obtain from JK flip-flop by just joins J and K terminal together. So this is your J and K terminal. If we think about this is a JK flip-flop, just join that. Okay, and it form a T flip-flop. So T flip-flop, that means one input is there and two output, one is Q and that is Q complement. Okay, now this is the truth table for T flip-flop. Okay, So the clock should be 1, and the two combinations for t is concerned 0 and 1, because this only one input is there. And when t value is 0, we got the next state also q, means whatever the present state value, the next state will be the same. If the present state is 0, so next state will be 0. If the present state is 1, then the next state will be 1. Okay, and if the t value is 1, then we got q complement, means this is the toggle, means whatever the present state, we will get complement of that. If the present state is 1, we will get 0. If the present state is 0, we get 1. Okay, so there the input is given and we got the output q and q complement. Now this is the characteristic table for T flip-flop which we got from this truth table. Okay, so what happened? The T have these two combinations, either 0 and 1, and when the T value is 0, so we get two present value, either 0 or 1. So in both cases, when we get 0 as present value and the T value is 0, we get the next value always the same. So that's why whatever the present value, we get the same, means 0. And when the 0 is there, and if the present value is 1, so also we get the 1. And when the t value is 1, and whatever the present value is that, we get the reverse of that. So if the present value is 0, we got 1, and if the present value is 1, the next value will be 0. This is the excitation table for T flip-flop, and which I got from this characteristic table. Okay, so when the present value is 0 and the next value is 0, so what will be the t value? So when 0 is there and also next value is 0, so the t value is 0. So there is only one combination, so that's why t is 0. When the present state is 0 and the next state is 1, so we got 1. So if this present state is 0 and the next state is 1, so you got t value is 1, and there is no other combination is there. And when present state is 1 and next state is 0, so we got also t as 1. So when present state is 1 and next state is 0, so we got t as 1 also. And the last combination, when present state is 1 and the next state is 1, we got t value is 0. So when present state is 1 and the next state is 1, so we got 0 as t value. Okay, I hope that you have understood today's topic. For more videos, keep watching my channel Technical Arquin. Okay, thank you and bye bye.